Hello friends, welcome to e-lecture series of ICA. In this section, I am going to discuss measures of dispersion, part 4, CPT section D, quantitative aptitude, chapter 11. Myself, Dr. N.V. Ravi, I am mentor for this section. In this section of measures of dispersion, I am going to discuss the important MCQs which we are going to discuss. Now coming to the MCQs one by one. MCQs 1. Which of the following statement is correct? A. Two distributions may have identical measures of central tendency and dispersion. B. Two distributions may have the identical measures of central tendency but different measures of dispersion. C. Two distributions may have the different measures of central tendency but identical measures of dispersion. If you see, look at these statements, all the statements A, B and C are correct here. That means two distributions may have identical measures of central tendency and dispersion also. Two distributions may have the identical measures of central tendency but different measures of dispersion. Two distributions may have the different measures of central tendency but identical measures of dispersion. Second, MCQ 2. Dispersions measures A. The scatterness of a set of observations. B. The concentration of a set of observations. C. Both A and B. D. Neither A and B. The right option, dispersion measures the scatterness of a set of observation. Here option A is the correct. Question number 3. When it comes to comparing two or more distribution, we consider A. Absolute measures of dispersion, relative measures of dispersion, C. Both A and B, D. Either A or B. When it comes to comparing two or more distributions, we consider relative measures of dispersion. Option B is the correct answer. Next, MCQ number 4. Which one is easier to compute? Which one is easier to compute? Relative measures of dispersion, absolute measures of dispersion, both A and B, range. Here, option is among the measures of dispersion, range is the easier to compute. So, answer D is the correct answer. Next, fifth one. Which one is an absolute measure of dispersion? Range. A. B. Mean deviation. C. Standard deviation. All these are range, mean deviation, standard deviation. Here quartile deviation also not given. All these are absolute measures of dispersion. So the answer is D is the correct answer. MCQ 6. Which measures of dispersion is most useful? Standard deviation, quartile deviation, mean deviation, range. Standard deviation is the measure of dispersion, very much useful in statistics. So A, standard deviation is very much useful. Question number 7. Which measures of dispersion is not affected by the presence of extreme observations? A. Range, mean deviation. B. C. Standard deviation, quartile deviation. When we study the properties of efficiency of various measures of dispersions, quartile deviation is not affected by the presence of extreme observation. This is the important property when we study the importance of various measures of dispersions. So quartile deviation is not affected by the presence of extreme observation. So this right option for this MCQ is D. MCQ 8. Which measures of dispersion is based on absolute deviations only. A option standard deviation, mean deviation, C quartile deviation, range, D is range. But when we look at the various measures of dispersion, in the mean deviation only, we are taking the value that is summation of modulus of x minus x bar by n. Here, this modulus of x minus x bar indicates the absolute values. So we can say that option B, mean deviation, when calculate the mean deviation, which is based on the absolute deviations only. So option B is the correct answer. Which measure is based on only the central 50% of the observation? A. Standard deviation, B. Quartile deviation, C. Mean deviation, D. All the observation. When using the measures of dispersion related to quartile deviation is Q3 minus Q1 by 2. So it is based on the 50% of the items. So the quartile deviation is the right option for this question. So option B is the correct. MCQ 10. Which measures of dispersion is based on all the observations? Option A, mean deviation. Option B, standard deviation. Option C, quartile deviation. Here, mean deviation and standard deviation taking all the observations of the data, whereas quartile deviation is not taken all the observations of the data. So option A and B are correct, but not C. So right option is D is the correct answer. Next, MCQ 11. The appropriate measure of dispersion for open-end classification is, here the options are A. Standard deviation, B. Mean deviation, C. Quartile deviation, D. All these measures. We have already discussed in the earlier lectures the mean deviation cannot come to consider, but standard deviation also not consider the open-end classification, whereas quartile deviation considers open-end classification. So appropriate measure of dispersion for open-end classification is quartile deviation. So option C is the correct answer. Next, MCQ 12. The most commonly used measure of dispersion: A. Range, standard deviation, C. Coefficient of variation, D. Quartile deviation. We have discussed the most commonly used measures of dispersion in statistics is standard deviation, which has mathematical properties also. So it is the most important one, standard deviation one. MCQ 13. Which measures of dispersion has some desirable mathematical properties? Standard deviation, B. Mean deviation, C. Quartile deviation. All these measures. Already we have discussed earlier slide also. Standard deviation measures of dispersion has some desirable mathematical properties. So option A is the correct one. Next, if the profits of a company remains the same for the last 10 months, then the standard deviation of profits of these 10 months would be the same constant in all the 10 years. So it should be the options A positive, B negative, C 0, D A or C. The option is the right option for the question is 0 is the correct answer. The right option for this question is option C is the correct answer. MCQ 15. Which measures of dispersion is considered for finding a pooled measure of dispersion after combining several groups? Option A, mean deviation. Option B, standard deviation. Option C, quartile deviation. Option D, any of these. Whereas if you look at the study material, the pooled means if you have two groups, the standard deviation can be, with the help of standard deviation can be computed, we can find out the measures of dispersion. So the appropriate answer for this question is option B, standard deviation is the correct answer. Next, MCQ 16. A shift of origin has no impact on option A, range, option B, mean deviation, option C, standard deviation, option D, all these and quartile deviation. If you look at just this is one example, already we have discussed the properties of range, mean deviation, standard deviation and quartile deviation. Y equal to A plus Bx is a linear equation between, there is a linear relation between y and x. We called as, this is called origin and this is called the scale. As per the properties of the range, mean deviation, standard deviation and quartile deviation is concerned, if range of y increases by x, then range of x is increases by b, then range of y is increased modulus b of range of x. In this case, range is increases in this category. So what I trying to say, this range of origin is not affected, but it is affected by only scale only. So coming to the same, coming to the point, this all these options, range, mean deviation, standard deviation, quartile deviation also, which is not affected by origin. So a shift of origin has no impact on range, mean deviation, quartile deviation and standard deviation also. Here quartile deviation is not given, but it also includes this option. So all these include and quartile deviation also. So option D is the correct answer for this. Next, the range of 15, 12, 10, 9, 17 and 20 is. You all know already well the range formula equal to highest value minus lowest value. If you look at this data, the highest value is 20, the lowest value is 9, the 20 minus 9 is the 11. So option D is the correct. So range for this data is 11. Option D is the correct. The standard deviation of 10, 16, 10, 16, 10, 10, 16 and 16 is, we have to compute this for this data, standard deviation. Before computing the standard deviation, first we have to know the formula for the standard deviation. Summation of, square root of summation of xi minus x bar whole square by n. First we have to compute the mean of these observations. That is, sum of the observation by number of observations. Here, sum of the observations are 10 plus 16 plus 10 plus 16 plus 10 plus 10 plus 16 plus 16 by here 1, 2, 3, 4, 5, 6, 7, 8 observations. Here, the sum of these observations are 104 by 8, which is equal to 13. So mean equal to 13 here. Just look at that. Next, what we have to compute further is standard deviation. Here, square root of x summation of x minus x bar. First, all the values, each observation is subtracted from the mean values. 10 minus 13 whole square, 16 minus 13 whole square, 10 minus 13 whole square, plus 16 minus 13 whole square, plus 10 minus 13 whole square, plus 10 minus 13 whole square, plus 16 minus 13 whole square, plus 16 minus 13 whole square, whole divided by n. If you look at this data, each observation is minus 3 square and this is plus 3 square. Here, all these minus 3 square or plus 3 square becomes 9 only. So every place it is 9, this 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 is 9. So 9, 8 places by 8, 8, 8 becomes cancelled. Square root of 9 becomes 3. So right option is C. For this data, standard deviation is computed with the help of the formula square root of summation of xi minus x bar whole square by n. First, we have to compute the mean for this data, that is sum of the observations by the number of observations is 8 observations. 104 by 8 is 13. So each square root of each observation is subtracted by mean whole square, and each category 9 is coming, so 9 is 8 times, so 8, the denominator is n observation is 8, 8 become 8, 8 cancelled, square root of 9 is 3. MCQ 19. For any two numbers, standard deviation is A. Twice the range, B. half of the range, C. square of the range, none of the range. If we have two numbers A and B, standard deviation of A and B is modulus of A minus B by 2. This is the formula, properties of the standard deviation. So the option is half of the range is the, for any two numbers, SD is always half of the range. MCQ 20. If all the observations are increased by 10, then ST would be increased by 10. Mean deviation would be increased by 10. C. Quartile deviation would be increased by 10. All these, option D, all this remains unchanged. Already we have been studied the properties of the mean deviation, standard deviation, quartile deviation, and range is concerned. What we called as y equal to a plus bx, this is called origin and this is called the scale. That means here whether increase or decrease or some variable in the equation, linear equation, the quartile deviation or range or standard deviation on mean deviation remains unchanged. So option D is the correct option. MCQ 21. If all the observations are multiplied by 2, this is the scaling factor, and then the new SD would be also multiplied by 2. New SD would be half of the previous SD. Option C, new SD would be increased by 2. New SD would be the decreased by 2. Already we have been discussed the properties of a range is concerned. So it should be the scale factor is concerned. So new SD would be also multiplied by 2. So option A is the correct answer. Now coming to the MCQ number 22. What is the quotient of range for the following wages of 8 workers? Rupees 80, rupees 65, rupees 90, rupees 60, rupees 75, rupees 70, rupees 72, and rupees 85. You know the formula for the quotient of range. Equal to highest minus lowest value by highest plus lowest value into 100. If we look at the data from here to here, the highest value is rupees 90 and lowest value is rupees 60. Based on this information, 90 minus 60 by 90 plus 60 into 100. 90 minus 60 is 30. 30 by 150 into 100. The option D is the correct answer. 20 is the correct answer. So option D is the correct. Now look at the MCQ number 23. What is the quotient of range for the following distribution? Here class interval and frequencies are given. Class intervals are 10 to 19, 20 to 29, 30 to 39, 40 to 49, 50 to 59. Respective frequencies are 11, 25, 16, 7 and 3. If we look at the class interval case, this class intervals is of the form inclusive class interval case. Now we have to arrange in the form of exclusive class interval. The lower boundary is reduced by 0.5 and the upper boundary is increased by 0.5. So in that case, this can be arranged as 9.5, 19.5, 19.5, 29.5, 30, 29.5, 39.5, 39.5, 49.5, 49.5, 59.5. Now if you look at the data, this upper boundary is 59.5, lower boundary is the highest, smallest one is the 9.5. The coefficient of range formula as follows. Highest minus lowest by highest plus lowest into 100. This here 59.5 is the highest minus 9.5 is the lowest class interval and 59.5 plus 9.5, which is equal to 50 by 69 and 100, which is equal to 72.46 is the percentage. This is the correct answer. That is option C is the correct for this MCQ. Now, if the range of x is 2, what would be the range of minus 3x plus 50? Here, the range of x is 2. In this category, minus of modulus 3 into x plus 50. So, range of 1 is minus of modulus 3 into x, range of x is 2. So, which is 6 is the correct answer. So, option B is the correct one. Next question as follows. What is the value of the mean deviation about the mean of the following numbers? Now look at the data. Mean deviation about the mean from the following data: 5, 8, 6, 3, 4. Before computing the mean deviation, we should know the value of the mean. This mean equal to x bar, which is 5 plus 8 plus 6 plus 3 plus 4. The number of observations is 5, that is 26 by 3, which is 5.2 is the mean. Now the mean deviation about mean is computed as follows: summation of modulus of x minus x bar by n observation, that is 5 observation, that is 5 minus 5.2 plus 8 minus 5.2 plus 6 minus 5.2 plus 3 minus 5.2 plus 4 minus 5.2 whole divided by 5 observations. If you look at all the sum of these deviations is positive only, that is 7.2 by 5, that is 1.44 is the answer. That is mean deviation from mean is this 1.44 for this data. So option C is the correct answer. What is the value of the mean deviation about mean for the following observations? Here 50, 60, 50, 50, 60, 60, 60, 50, 50, 50, 60, 60, 60 and 50. If we look at the data mean deviation about mean for this data, first we have to compute the mean for this data. 2, 3. What is the value of the mean deviation about the mean for the following observations? 50, 60, 50, 50, 60, 60, 60, 50, 50, 50, 60, 60, 60, 60. If we look at these numbers, the 50s are repeated 7 times, 60s are repeated 7 times. So there are 14 observations. First we have to find out for the computing the mean deviation, we have to compute the mean. X bar equal to sum of the observations. So this is 50 is repeated 7 times plus 60 is repeated 7 times, total 14 observation. The average of this observation is 55. Now we have to compute the mean deviation from mean. The formula is summation of xi minus x bar modulus of by n. Here each observation is subtracted from 55. So this is the absolute value of 5 only in all the cases. So 14 times, and number of observations is 14 here. So 14 get cancelled. So the 5 is the right option. Option A is the correct. The once again I am explaining here. If you look at this data, the 50 is repeated 1, 2, 3, 4, 5, 6, 7 times. So this is 57 times, and 60 also repeated 7 times. The mean is the 15 to 7 plus 16 to 7 by 14, which is equal to 55 is the mean. And mean deviation from mean formula is summation of xi minus x bar by n, 14 observations, and each observation is subtracted by 55. So after subtracting, each value is 5 only. 14 times, this way 14 get cancelled. The 5 is the mean deviation from mean for this data. So option A is the correct answer. Next, look at the MCQ number 27. The quotient of mean deviation about mean for the first n natural numbers. You know, students, the sum of the first n natural numbers is sum of n into n plus n by 2. Here we have to find out the mean deviation about the mean. For that, first we need the sum of the 9 observations also. So 9 observation sum is 9 into 9 and 9 plus 1 by 2. This is 9 into 10 by 2. This is 2 5. 45 is the observations. So summation of these 9 observations is summation of 45 by 9 observations. That is 5 is the exactly mean for this data. And now look at this mean deviation from mean. The formula is a summation of xi minus x bar by n, 9 observations here. Now we have to compute the absolute value as 1 minus 9 plus 2 minus 9, sorry, 1 minus 5, 2 minus 5 plus 3 minus 5 plus 4 minus 5 plus 5 minus 5 plus 6 minus 5 plus 7 minus 5 plus 8 minus 5 plus 9 minus 5, and each observation is subtracted by divided by 9 observations. So after computing this 1 minus 5 minus 2 minus 5 plus 3 minus 5, all this sum is equal to 16 by 9, and this is the MD from mean. Well, and now we have to compute the formula mean deviation from mean by quotient of mean deviation about mean. That is quotient of mean deviation from mean equal to mean deviation from mean, this formula, by mean value into 100. Here this value is 60 by 9 by 5, by mean is 5 into 100. 60 by 9 into 1 by 5 into 100, which is as follows: 5 12s, 3 3s are, sorry, 4 3s are 3 4s are 12, and 3 3s are 9. So this is 400 by 3 is the correct answer. So option C is the correct one. 400 by 3 is the correct answer. So option C is the correct one. Now, if the relation between x and y is 5y minus 3x equal to 10, and the mean deviation about mean for x is 12, then the mean deviation of y about mean is. Now we have to compute this mean deviation of y about mean. Here x value is given. First we have to express this data in the form of y equal to, see, look at 5y equal to 3x minus 10, y equal to 3 by 5 into x minus 10 by 5. Now we want to find the mean deviation about y. Y in terms 3 by 5 into 12. So 3 by 5 is 0.6. 0.6 is into 12 which is 7.2. So 7.20 is the option A. So option A is the correct one. If two variables x and y are related by 2x plus 3y minus 7 equal to 0, and the mean and mean deviation about mean of x and x are 1 and 0.1 and 0.3 respectively, then the coefficient of mean deviation of y about mean is. Let us come to the question number 29. If two variables x and y are related by 2x plus 3y minus 7 equal to 0, and the mean and mean deviation about mean of x are 1 and 0.3 respectively, then the coefficient of mean deviation of y about mean. Now let us look at the formula. The mean deviation of y, mean deviation from mean, that is md from mean by mean into 100 is the formula. Just remember this formula is very important. Now let us look at the equation which is given in the sum. 2x plus 3y minus 7 equal to 0. Now 3y equal to minus 2x plus 7. Now in this question which is given, mean and mean deviation about mean of x are 1 and 0.3. Mean of x is 1, then mean of y equal to, we have to find out. Then from this we have to write the expression in the form of this. If 3 comes this side, this will be division, minus 2 by 3 into x plus 7 by 3. Now we have to find out the mean of y. Mean of y is, x is given, that is minus 2 by 3 into 1 plus 7 by 3, which is equal to minus 2 plus 7 by 3, which is 5 by 3 is the mean. Now this is the mean of x. Now we have to find the mean deviation of y. Mean deviation of y is, mean deviation of x is given, md of y we have to find. This is modulus of 2 by 3 into 0.3, which is equal to 0.1 times, which is equal to 0.2. Now we have to find the mean deviation of y based on this formula. This is a 0.2 is mean, md of x, y is 0.2 and mean is 5 by 3 into 100, which is equal to 12 is the right answer. Option B is the correct answer. MCQ 30. The mean deviation about mode for the numbers 4 by 11, 6 by 11, 8 by 11, 9 by 11, 12 by 11 and 8 by 11. We have to find the mode, mean deviation of both modes for the following data. Let us look at the formula. Mean deviation from mode is nothing but modulus of x minus mode by n observations. Now based on here mode is the one which item is number of times repeated mode. Here the 8 by 11 fraction is repeated 2 times, so mode for this data is 8 by 11. Just look at where this value. Next MD from mean deviation from mode equal to here 1 by n is n is the item which is 6 number of times 1 2 3 4 5 6 items are there, and in every case here if you look at this 1 by 11 is the common here, so next which is modulus also 4 minus 8 4, 6 minus 8 2, and 8 minus 8 0, 9 minus 8 1, 9 minus 8 1, and 12 minus 8, this is 4, and plus 8 minus 8 0, and in this way we can compute, and 1 by 6 into 1 by 11 into 4 plus 2 6, 6 plus 4 10, 10 plus 1 11, and 11 ones, so option A is the correct. 1 by 6 is the answer for this question. What is the standard deviation of 5, 5, 9, 9, 9, 10, 5, 10 and 10? Let us look at the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. Sorry, here n equal to 9. The formula for the standard deviation equal to square root of summation of x minus x bar whole square by n. Before that we have to compute the value of the mean x bar equal to summation of all the observations by n number of observations. If you look at the formula, that is sum of the mean formula here, first we add all the numbers 5 plus 5 plus 9 plus 9 plus 9, 10 plus 5 plus 10 plus 10 whole divided by 9 observations. The sum of the observations is 72 here. 72 by 9 is 8 is the mean. Now we have to compute the standard deviation as follows. SD equal to summation of, here denominator part is 9, and every item is subtracted by this mean item, that's 5 minus 8 whole square plus 5 minus 8 whole square plus 9 minus 8 whole square plus 9 minus 8 whole square plus 9 minus 8 whole square plus 10 minus 8 whole square plus 5 minus 8 whole square plus 10 minus 8 whole square, 10 minus 8 whole square. If you look at this data, here 5 minus 8 whole square is repeated in 3 times. This is 3 into 2 square, and similar way 9 minus 8 whole square is repeated 3 times, 3 into 1, 3 into 1 whole square, and rest is, if you look at this 5 minus 8 is repeated, 5 minus 8 is repeated 3 times. Here 5 minus 8 whole square is repeated 3 times, 3 into 3 square plus 10 minus 2 whole square is also repeated 3 times, so 3 into 2 square by 9. The sum of all this square, this is 42 by 9, this is square root of 42 by 3, so option B is the correct answer for this question. Let us look at the MCQ number 32. If the mean and SD of x are A and B respectively, then the SD of x minus A by x minus A by B. Here the mean is x of x are A and B. Mean is x A and SD is B. Now SD of x minus A by B we have to find. XD of x minus A by B can be written as x by B minus A by B. This is what we call as the origin, this is scale. So scale is affected 1 by B times of the SD of x is b one time, so 1 is the correct answer. So option B is the correct one. So option B is the correct. This is 1 by b into modulus of 1 by b into b, one time cancel, so 1 is the SD. Option B is the correct answer. What is the coefficient of variation of the following numbers: 53, 52, 61, 60, 64? Now we have to calculate the CV for this data: 53, 52, 61, 60 and 64. You know, the coefficient of variation formula can we call as simply CV. CV equal to sigma by x bar into 100 is the standard formula for the coefficient of variation. Now, before that, computing the CV, first we have to calculate the mean value. X bar equal to 53 plus 52 plus 61 plus 60 plus 64 whole divided by 1, 2, 3, 4, total 5 observations here, and which is equal to 290 by 5, which is 58. Now further we have to compute the standard deviation. The standard deviation is summation of x minus x bar whole square by n. Here n is 5 and each observation is subtracted from this mean value, respected mean value, and 53 minus 58 whole square, 52 minus 58 whole square, 61 minus 58 whole square plus 60 minus 58 whole square plus 64 minus 58 whole square, and sum up of all these things after simplification, which is equal to square root of 22, which is equal to 4.69. Now we have to calculate the CV. CV equal to 4.69 by 58 into 100, and which is equal to 8.09 percentage. So option A is the correct one. MCQ 34. If the SD of x is 3, what is the variance of 5 minus 2 x? In the similar way, here also range is affected by the value. What is the variance is affected also here. Now minus 2 into 3, and which is equal to 6, and variance of x is we have found it that this is the SD of x. Now we have to find the variance of x. So in this way here, which is 6 square, that is 36 is the right answer. MCQ 35. If x and y are related, y 2x plus 3y plus 4 equal to 0, then SD of x is 6, then SD of y. Here we have to first see the equation 2x plus 3y plus 4 equal to 0. Now we express this equation in terms of y. 3y equal to minus 2x minus 4, and y equal to minus 2 by 3 into x minus 4 by 3. Now here SD of x is given, SD of y we have to find. SD of y equal to, this is modulus of minus 2 by 3, so 2 by 3 into SD of x is 6, 3 2s are, so SD of y is 4. Option B is the correct answer. MCQ 36. The quartiles of a variable are 45, 52 and 65 respectively. Its quartile deviation is, quartile deviation equal to Q3 minus Q1 by 2. Here first one is Q1, second one is Q2, third one is Q3. So Q1 here is 45, Q2 is 52, Q3 is 65. So Q3 minus Q1 by 2, quartile deviation equal to 65 minus 45 by 2, that is 20 by 2 is 10 is the quartile deviation for this data. If x and y are related as 3x plus 4y equal 20, 3x plus 4y equal 20, and the quartile deviation of x is 12, then the quartile deviation of y. Now we have to express, see the equation 3x plus 4y equal to 20. Now we have to express this equation y of x, 4y equal to minus 3x plus 20, y equal to minus 3 by 4 into x, 20 by 4. Now we have to find the quartile deviation of y. Quartile deviation of x is 12 has given. Quartile deviation of y is based on the properties of the mean deviation from mean deviation, quartile deviation, standard deviation and range. All these are affected by scale factor only, not on the origin factor. Based on that, so 3 by 4 modulus of value this into 12 and 4 3s are, so quartile deviation of y is 9. Option D is the correct answer. MCQ 38, if the SD of the first n natural numbers is 2, then the value of n must be, you know, the formula SD of n natural numbers is square root of n square minus 1 by 12, which is equal to, SD is given here is which is equal to 2 by squaring on both sides, n square minus 1 equal to by 12 equal to 4, n square minus 1 equal to 48, n square equal to 49, n equal to 7, plus or minus 7, but we take the positive value only, so n the number of observations is 7 must be, then the value of SD will be equal to 2. MCQ 39, if x and y are related, y equal to 2x plus 5, the SD and AM of x are known to be 5 and 10, and the coefficient of variation is, here y equal to 2x plus 5 is given. If mean of x, AM of x is to be 10, then y equal to 2 into 10 plus 5, which is equal to 20 plus 5, which is 25. So based on that, mean of x is 10, then mean of y is 25. Now we have to find the SD of y. SD of y. SD of y is 2 into SD of x is given is, SD of given y is 5, so 2 5s are 10. Now based on the formula, the coefficient of variation CV is sigma by x bar into 100, that is standard deviation by mean into 100. Then standard deviation is here 10 by 25 into 100, which is equal to 40. So option C is the correct one. The mean and SD for A, B and 2 are 3 and 2 by root 3 respectively, then value of AB would be. Now we have to find this AB value for the based on the given data. The mean is formula A plus B plus 2 by 3, which is equal to 3. Simply from this data, A plus B equal to 9 minus 2 implies A plus B equal to 7. Just look at, this is the first one, and this is based on the mean formula we have found out. And next is we have to find the value of SD given based on the given data SD, and SD is formula A minus 3 whole square plus B minus 3 whole square plus 3 minus 2, 2 minus 3 or 3 minus 2 same, and by 3, which is equal to 2 by root 3. Okay, and let us look at the value. This is denominator side, this is also root 3, this is also root 3, but I'm noticing squaring on both sides, and which is equal to this, both the values are cancelled, so I'm looking these values only. A minus 3 whole square plus B minus 3 whole square plus 3 minus 2 whole square is 3 minus 2 whole square is 1, which is equal to 4. And you know the formula A minus B whole square equal to A square plus B square, minus 2ab. Just we apply here this formula, a square plus b square. A square plus b square is here 3 square, and minus 6a plus b square minus 6 b square plus 9 minus 6b plus 1, which is equal to 4. Now I can write a square plus b square in one place, and 9 plus 9 18, and minus of, and 6 into 6 into a plus b plus 1, which is equal to 4, and a square plus b square plus 18. 6 a plus b value is already found 7. 6 sevens are 42 plus 1, which is equal to 4. Now after simplification, the a square plus b square value is 27. Now we have to find the value of AB. In order to find that value, we know the value of a plus b value also. A plus b whole square equal to a plus b, a square plus b square plus 2ab. A plus b whole square value is 7. A plus b is 7. 7 square, and a square plus b square value is 27, and plus 2ab, and which is 49. 49 minus 27, which is equal to 2ab, implies 2ab equal to 22, ab equal to 11. So option C is the correct one. And students, look at this sum has been solved based on the given data. A plus b plus by 2, a plus b plus 2 by 3, which is equal to 3, and which is equal to a plus b equal to 7 we have found. After that, simplification based on the standard deviation formula, that is each observation subtracted from respective mean value on the mean value and by the number of observations. After that, we solve this value, then we found that AB equal to 11. With this, I conclude the lecture on the topic measures of dispersion. Thank you very much, students.